Alright guys, so we've talked about the 4 different types of solids and kind of what holds them together, what makes them a little bit different. Now, what do I need you to be able to do with this? First and foremost, understand most of the questions that are going to come from pretty much this whole unit are going to be more in the multiple choice section, not so much in the free response, but don't think that they're not going to show up in the free response. They can. And we'll work on some of those here in a little bit. So what I need you to be able to do is, let's say I tell you something has a melting point of 300 degrees Celsius. And I tell you it is soluble in water. And I tell you that it does not conduct electricity in any state, whether solid, liquid, dissolved, or anything like that. So let's kind of go through it. First off, we have molecular solids. We have ionic solids. We have metals. And we have network. So let's kind of go through this. Remember, our intermolecular forces, these are increasing, and intermolecular forces are, I should say, forces in general. Force is strength, which of course I can't write sideways, sorry, but you get the basic idea. Forces are increasing, going down. Molecular are our weakest, so they have our lowest melting point and boiling point. We have our ionics, which are kind of a medium. Melting point, low boiling point. We have our metals, which are our higher, I'm just going to say higher, not highest, melting point and boiling point. And then, of course, we have our networks, which are our highest melting point and boiling point. Okay, so, hold on, sorry guys, let me pause. Okay, sorry about that, guys. I do have Riley in my arms right now. She is kind of half asleep, but if you hear any weird noises again, that is her. I apologize. She's going through a growth spurt and a little bit fussy at this moment. Anyways. Okay, so that takes care of our melting point and boiling point. Still not enough for us to really work with our numbers to kind of figure out what that is. So the next thing I want to discuss, which I didn't discuss when we were talking about them, which I apologize, is solubility. So remember what solubility is. That's the ability to dissolve, and specifically we are referring to the ability to dissolve in water. So what makes something be able to dissolve in water? It has to deal with the polarity. So are molecular solids soluble in water? Well, some are not. So we'll put soluble, and we'll put a question mark down here, because that depends on whether they are polar or nonpolar. So some can be, some may not be. So ionic compounds, are they soluble in water? Again, that kind of depends. But for the most part, we're going to put a yes. Because for the most part, most ionic compounds are soluble. We do have the few that are insoluble, and we'll actually talk about in this chapter what makes those insoluble. Metals, are they soluble in water? Most definitely not. Okay, there's not even a question in that. If I drop a piece of metal into water, it's not going to magically dissolve. Okay, next one is network solids. Are they soluble in water? So again, this is like our quartz or our diamonds, or the graphite from your pencil. Again, most certainly no. Okay, so we have this melting point being 300 degrees Celsius. Whether that's high or low, we'll come back and discuss that momentarily. Whether it's soluble in water. So this one is soluble. That means it's either going to fall into the molecular or in the ionic state. Okay, the next thing is conductivity. Again, I apologize for the weird baby noises. Conductivity, can it conduct? For molecular solids, that is a definitive no. For ionic solids, remember that is a yes, but only in the liquid or dissolved state. Okay, and these are basically, you need to memorize or get the basic gist of these properties. Metals, can it conduct? Yes. Okay. And network solids, can they conduct? No. Okay. So once we kind of go through and kind of discuss all those different properties, let's see what we can figure out. Melting point, boiling point, determining whether it's high or low, that could be a little bit of a challenge, so I'm actually going to skip that for right now. We're going to come back and talk about it. The next thing I want to talk about is the solubility. Again, we just discussed this, whether it's soluble or not. That means it's going to fall either under a molecular solid or an ionic solid. And then, of course, does it conduct? This particular solid that we're trying to identify does not, so therefore it's going to fit under our molecular solid category. So we know it's going to be a molecular solid. Now, what we would have from there is we'd have a list of A, B, C, and D, because again, these are most predominantly going to be in our multiple choice section. And the first one might be sodium chloride, and the next one might be sugar. And the next one might be iron, or copper, or whatever it wants to be, and the next one might be diamonds. Okay, so from there, we know it's going to be a molecular solid. Well, which one of these four is a molecular solid? Well, sodium chloride we automatically know is ionic. Okay, we know sugar is a covalent compound, and held together by it is a covalent compound held together by intermolecular forces, so we know it is a molecular solid. Iron, of course, is a metal, and diamonds fits into our networks. And again, the most common networks you're going to see on these are going to be diamonds, graphite, and either silicon dioxide, or they may call it quartz. It kind of depends on who's writing it. Okay, so those are kind of the three we need to know. Okay, so in this case, we already said these three categories fit under our molecular solid. So that means we come down here, we figure out a molecular solid, and we say sugar. Okay, so let's do it again. And we're going to keep these four as our multiple choice selection choices. Let's pick out some more properties. Let's say it melts at 2,000 degrees Celsius. Okay, and that's its melting point. Okay, let's say it does not conduct. And does not dissolve in water. Okay, take a second, see if you can figure out who that's going to be based off of our properties that we have over here off to the right hand side, and we'll come back and discuss that in just a moment. Okay, so 2,000 degrees Celsius, fairly high melting point, and we'll get a little bit more comfortable on what makes it high and what makes it low. Typically, if it's in the thousands, I would say it's fairly high, so somewhere in that ionic metal network range. And of course, I'm making up these numbers, so that may actually not be as high as what the one I'm looking for. Does not conduct. Okay, so again, does not conduct would either be a molecular solid or a network solid. Is going to have to be one of those two, because ionics would say that it conducts as a liquid or as a solution. And then, of course, it does not dissolve in water. So again, what that's going to fall into is it could be molecular, because it could be soluble, but it could also not be. It could be a metal, and the fact that it's not soluble, or could be a network solid, and the fact that it is not soluble. Of course, we can rule out metal, because metals would be able to conduct electricity, and this one does not conduct. So it's either a molecular solid or a network solid. So how do we know which one? Check out that melting point. That's a fairly high melting point. Typically in the thousands, again, would be considered high. Most of your molecular solids are not going to be that high, because they're just intermolecular forces, so fairly weak, fairly low amount of energy to break them. So I would say we're looking at a network solid. So from there we go to our list, find our network solid. I would say we're looking at diamonds. Okay, so that's kind of what you're doing with these, is you're taking properties and kind of identifying what properties go with what type of solids, and then looking at your multiple choice section. Now again, that is one of the things you could probably see in terms of the multiple choice. You have other things that you would see as well. Sorry, let me clear this. Other things you might see is they might ask for particulate representation. So it might ask you to identify which picture shows cleavage, or which one shows why ionic compounds are so brittle. So again, remember what makes ionic compounds brittle. It has to deal with those alternating charges. Okay, and then two charges that are identical ending up next to each other that repel and shoot off from each other. So you'd be looking for something like that. It might ask you to identify a solid based off of a picture. So you'd be looking at something like this being an ionic compound. A metal would have that closet packing system or closet packing system. Sorry, I pronounced it a little bit weird. So you might be looking for something along those lines. An ionic compound, that molecular solid. Sorry, give me a second. Alright. Molecular solid would be something where you actually have individual compounds that are very definitive, that are being held together, typically by dashed lines of some sort, and that's how you would identify it's a molecular solid. And then, of course, your network solid would either be definitive solid lines, either holding molecules or atoms together one way or the other. So you'd be looking for some type of picture to identify which one it is. You could also be asked to identify alloys. So let's say I tell you it's a substitutional alloy. Okay, well, which one of these pictures shows a substitutional alloy? And you have picture A, which I apologize, it's a little bit of a mess. Okay, or you have picture B. Where what I'm drawing in are smaller atoms filling in the spaces. So which one makes a substitutional? Well, this guy. So what is this one? It's our interstitial. So you might be asked to identify them based off of that as well. And we'll work through those. I've got a couple multiple choice practice problems that you're going to be working on later today as well. Let's go through this real quick. Okay. So this is one of the multiple choice questions from one of the past tests. Which of the following could be the identity of a white crystalline solid that exhibits the following properties? It melts at 320 degrees Celsius. It does not conduct electricity as a solid. And it does conduct electricity in an aqueous solution. So pause the video. See if you can figure out what your answer is. Okay, so again, melting point is not going to be my first resort. It's not going to be the first thing I look at. I'm going to kind of think about my my types of solids. So I have molecular, I have ionic, I have metals, and of course I have my network. So I'm going to kind of rule it off, and typically one of the easiest things to do to rule it off is conducting electricity, and you have two different aspects here that allow you to conduct electricity. So first off, will a molecular solid ever conduct electricity? No, so I'm going to rule that guy off in general. Can an ionic compound conduct electricity? Yes, specifically as an aqueous solution, so I'm going to put a check as that's a possibility. Can a metal conduct electricity? Yes, as a solid, specifically. Well, notice here, does not conduct electricity as a solid, so I'm going to rule that out. Okay, network solid, does it ever conduct electricity? No, so this whole aqueous solution, we rule that out as well, Riley. So our answer here is actually fairly straightforward because there's only one option left, which is ionic compound. So again, not really paying attention to that melting point, I'm paying attention to the conducting electricity. It is the easiest thing to use to really identify it and figure it out. Okay. So an ionic solid is what we're looking for here. So we come over here and we say, okay, well, this is sugar. It's molecular. Okay, sodium hydroxide. It's ionic. There's our answer. Silicon dioxide. Remember, this is one of the ones you need to memorize and recognize because at first it looks like a covalent compound, but this is actually a network. This is quartz. Okay, and then, of course, copper is our metal. So our answer here is B. So not too bad. So again, you could be identifying pictures, you could be identifying properties. You also need to be able to draw these pictures and kind of be able to work through them and explain them through drawings because they do show up on the multiple choice, or they do show up on the free response on occasion as drawings, but again, not as common. It'd probably be only a few points, but it could be one of the short problems that shows up on the exam. So it would be something I would definitely work on, and we will have some more practice problems with that as we work through this chapter. So for right now, that's it. Hopefully we are getting a good grasp on this, and we're going to work on some questions from here. Thanks.